Okay, so now we've solved the problem, we put everything together. Let's go now and look at that sensitivity report. Now remember, we had the sensitivity report. It was generated from the model that we ran before we turned it into an integer program. Because once we turn it into an integer program, if you recall, we're not going to get this anymore because it can't handle it because of what's going on. And so let's look at a couple of different things. So once again, let's look at the reduced cost column. So let's I'll highlight that with orange. So what does this mean? So this works for all the different ones. So, but this specifically Dancing with the Stars, reduced cost. What does that mean? Well, the cost per ad would have to decrease by at least 10. And so remember, that's 10, that's actually $10,000 before it would be optimal to have an ad on Dancing with the Stars. Before it would be optimal to purchase an ad on Dancing with the Stars. Okay, so we have that. Now that's going to be with any of these. And so you'll notice that the reduced cost only appears on ones where our value is 0. And so it's by a different amount. So if Homeland dropped to only $5,000 an ad, is that, yeah, forgot a 0 over here. That's 10,000. We've only got written 1,000. So that'd be 10,000, so it would have to reduce by $500 an ad before it's optimal to have it in there. Okay, and so then let's look at, so that's our reduced cost. So let's go and let's look at one of our allowable increases and decreases, and you know what, Sports Center will be a good one. So why don't we look at that one there. So what is this? Remember, this is the allowable increase or decrease, indicates how much the Sports Center cost per ad would have to change before the Sports Center ad would change. So allowable increase and decrease indicates how much the Sports Center cost per ad would have to change before the optimal number of ads would change. So if we take a look at it, that means that if the Sports Center ads have gone up by more than 0.761, that would mean that we would buy less Sports Center ads. Or if the Sports Center ads would go down by more than 0.5, then that would change because we'd probably buy more ads in there because the cost mix has changed. And so once again, we have this granularity in here in these decimal places because this was generated off of our non-integer solution. So we do have that continuous distribution that we can take a look at. Okay, so let's go down here. Let's look at shadow price, and we'll do it for the men 18 to 35. And so the shadow price, this is all talking about how much things would change with the objective. So if the company were to relax this constraint by 1, and so that would be 1 million exposures, the objective value, which in our case is the cost, would decrease by 15. And so in the case of our ad cost here, that 15 would be 15 units, so $15,000. Similarly, if we were going to increase the constraint by 1, the shadow price tells us that the cost would increase by $15,000. And so that's, once again, that shadow price is really tagged to our constraint, to our final value. And so we can move things up or down. Now, as we go and we look at this, so we have that shadow price men 63 to 55. If we come here, men 63 to 55, in the original case, because see now we got 60.4 exposures, in that original case, it was final value of 60, we had 60 exposures. So we ran right up to the limit. And I bring that up because if you notice the shadow prices where we have, here's the women 60, 60, and 28. If we go back to the thing, 60, 60, 28. So you'll notice we only have a shadow price on these values where we hit the constraint. And actually, the constraint right hand side is here. So where we have a binding constraint, because where we have these non-binding constraints, the shadow price doesn't really mean anything because we're not being limited by our constraint. So once again, let me put the verbiage here. So if the company were to relax this constraint by 1, which is 1 million views, the objective value, which is our cost, would decrease by 15, our shadow price. And that 15 in this case is $15,000. Similarly, if the constraint was increased by 1, the objective value would increase by 15. Okay, so we've got that verbiage in there, taking a little bit of room, but that's fine. Okay, and so that's what our shadow price does for us. And so if I look at, and that's why there's no shadow price for these ones that do not hit, that are not being bound, because it doesn't matter what you do with men over 55, because you're already three units or 3 million views over the constraint. Here you're 13. So there's not really going to be any movement because it's not bound at that point. And so the last one is, let's look at allowable increases and decreases. We'll choose women 18 to 35. We'll make that a different color too because I've been using the same color for everything. A little lighter there. Okay, and so what is this? Well, this just shows the allowable increase and decrease in women actual exposures from 18 to 35 before that shadow price would change. Indicates how much this value or this constraint can change before the shadow price changes. So this is all just talking about how sensitive our different variables are to these changes. So this is great information to have. Now, with our final model here, which we use the integer solution where things are different, are these numbers still going to be legit? No. Because there's a lot of rounding errors that have happened with the integer solution, but it does give you a general sense of what's going on and what's going to happen as we make these changes. Sensitivity reports are great. Unfortunately, they're really only good for a general optimized solution, which is why it is good when we're running an integer solution like this to be able to run the integer solution first, generate the sensitivity report so we kind of have an idea of what's going on, and then running it again with the integer solution so we get a complete picture of the problem. And there we have it. If you have any questions, please let me know. Otherwise, we'll see you in the next video.